All right, welcome everyone to our webinar on generating UI tests with AI. My name is Mika Andersson. I'm from marketing, and today I have Manalo Carrasco with me. And Manalo is responsible for all our releases. So whenever you see a new release coming out from Vaadin, you know it's made by Manalo. And as a quick reminder, we just published our latest beta release, 24.7 beta release, last Wednesday. So it's fresh out from the oven. But without further ado, let's get into the housekeeping stuff. So just a quick reminder on housekeeping. We are keeping all the lines muted during the webinar, and we are very happy to receive your questions during the webinar, and we will address those questions after the webinar during the questions and answers section of the show. And if want to continue the conversation after the webinar, we welcome you to join the conversation on Vaadin forum. There is a link on the screen. And as usual, after the webinar, roughly around within a few hours, but no more than 24 hours, we will send out the recording as well as the webinar slides to you. So that's all about the housekeeping. I'll hand it over to you, Manalo.
Okay, thank you, Mika. So yes, hello everyone. This is Manuel Carrasco, and what we are doing today is to talk about AI and UI. Okay, so here is what we will cover. So we will start by talking about AI in software development, and then we will discuss why automated UI testing is important. And we will look into how AI-driven UI testing works. And after that, I will introduce the Vaadin UI Test Generator, a prototype that we are developing in a multinational research project named Smart Delta. And there will be some demonstrations. I will do as fast as I can because we have limited time. And some final thoughts. So let's start with an introduction to AI in software development. So because AI is changing the world today and obviously also in the coding field. So to make it very simple, we can say that there are two main AI technologies or types. We have large language models or LMs and AI generators. LMs are great at speaking and understanding human or computer languages, and they are used in things like chatbots, translations, and obviously programming language processing. And on the other hand, generators can create different kinds of content, including text, images, music, videos. Basically, generative AI is used for creating artistic content nowadays. And also there is a concept called discriminative AI designed to classify and predict results based on existing data, but it doesn't have creative abilities. And based on this, LMs are a specific type of AI that was discriminative in origin, but nowadays it includes some generative algorithms or random things that make it create kind of things. This means that we can find very different models depending on how we combine technologies. And looking ahead, large language models will continue to improve in understanding languages, both natural and software, and making conversation with human and computers better. And since generators will help us to be more creative, inspiring new ideas in different fields, etc. And to conclude this introduction, we know that LMs understand not only human languages, but also computer languages. And these LMs have a huge database of information, like in our case, all the code in GitHub that is public. An immediate application is to use them for code generation, which is what we are going to do today. If we also add machine learning algorithms, AI could eventually write code automatically, helping developers to do more. But nowadays it's not the case. So learning processes is not, well, they are working on it, but it's not a reality nowadays. So next, let's talk about the importance of automated testing. Basically, we have two kind of testing. One is unit testing, and the other is integration testing. And unit testing is done during the development phase in order to check a small part of our code that they work correctly. And there is this test-driven development, which helps in writing reliable and good code, good software, if you already do that. In the other part, UI testing is part of the integration test and takes place after the whole system is together, checking if everything works properly from the browser to the backend. And both unit and integration tests are crucial for good software development. And what about legacy? So for legacy code, testing is the key for keeping up and updating the code. So when we face modification to legacy code, which is not full covered, we need tests. And to have those tests, AI can help. So we can start with functional testing in order to cover faster our software. So yes, a unique UI test can cover all the stack. And then when we have this tested, we can slowly add a specific unit test for deeper checks in this legacy code. So it's a process that before migrating code, is better to have those tests. Because this process aims for wide coverage with minimal effort to start. AI helps to improve UI testing by automating the creation of tests, reducing how much manual work is needed. And this approach leads to broader testing, improving software quality and increasing coverage. In summary, it helps to save your time. Now let's dive into AI-driven UI testing. I'm going to run this section by doing some experiments and using a real showcase application and obviously AI technologies. But before doing this, I am going to show a demo of the application that we are going to use. So we connect to starvaadin.com. For creating a new application, I am with my user. So here you can see that I have some already project here. There is a Vaadin showcase. I click on it. I create this by selecting all the views that we can create in starvaadin.com. So all the flow views and also a couple of Gila views that we can create from there. And then once that I have everything there, just change the artifact ID, the group ID, and also the version. And I download it. Okay, so we have this application in my local. And I am going to describe the tools that I am going to use. So I am going to use ChatGPT Playground to try out AI prompts, Gherkin, which is a language for describing software behavior, and Playwright, which is a UI framework, testing framework. So the ChatGPT Playground by OpenAI is an interactive tool to experiment with ChatGPT models. It allows you to customize settings and helps with tasks like text generation and coding. And this tool is excellent for quickly trying out ideas and checking what AI can do for you. Gherkin is an easy-to-read language for describing the software, and it uses natural languages with keywords like given, when, them, etc. And it makes it easy for everyone on a project to understand what is expected and helps with automating tests. And Playwright is an open source tool for testing websites. It works with different browsers and supports many programming languages. It offers many features. It supports languages such as Java, .NET, TypeScript, JavaScript, Python, making it flexible for different developers and projects. And it ensures that tests run consistently across different platforms. So let's watch another demo. And we are demonstrating the playground in AI-driven testing. So it has two phases, as you can see. Let's start. Okay, I connect to the playground website, this platformopenai.com. And once that I am going to set some parameters. I am interested in the maximum length of tokens, so as we can send large prompts. And then I describe what to do, what the AI should behave. So it is a specialist of Vaadin Flow, Playwright, Java, etc. And then let's start writing prompts. So what I am doing here is that I give the flow view in backtick. So I go to my projects. I have my project in my ID, and I get a random view from here, for instance, the chat view. I copy the code and put the code inside the prompt. And then what I need is the view itself. So I am going to paste here the code, the HTML code. In order to do that, I need to run my project. Let's start my project. Okay, so I have my project here. This is the showcase, and I'm going to visit this chat view. And now I inspect it with the Chrome inspector. And then I take the full container of flow and copy it and paste it in my prompt. And then I paste here the rest of the prompt that I have in mind. So when I run it, I get the Gherkin. I ask for a Gherkin file. So I have here this Gherkin file, which describe how should I test my view. And then now that I have my Gherkin, I have it in my computer. So now I describe the again to the AI. I use the AI with the same system instructions, and then I paste here this prompt for create a JUnit test class using the Playwright Java API, and then I provide the Gherkin file. Okay, I copy and paste, and finally I run. And what happened is that the AI is giving me a Java test file. And this test file looks fine in theory. So at least I have some test cases, etc. And now I'm going to explain what we did in the demo. So this is the prompt in the demo. So as you can see, this is what we wrote for the system, and in the user we give some instruction. This is the flow view. This is the HTML. I copied here in these spaces. So you have this in the presentation. You can experiment with the same prompts if you want. And then I ask the AI to create a comprehensive Gherkin scenarios, etc. And this is the result that we saw during the demo. So you can see that we have the setup. So the feature is chat view functionality. The background is given the user is in the chat view, and then it describes scenarios based on the code that it processed, and also in the code from your view, and also for the HTML. And yeah, it's a valid description of how to test your UI. And then the second part of the demo was that we take the Gherkin file, we paste here the Gherkin file, and then we ask to analyze the Gherkin scenarios, which is already tested in a Vaadin view, and then create the GUnit test using the Playwright Java. We set here where is the application running. I ask for add comments to the view, to the test, and then use locator as much as possible and the assertion API. And we get this test Java file. So you can see that it's use Playwright annotation is a proper JUnit test, and it has before all setup, also teardown, etc. And then we have the same scenarios than before, but now we have the code for those. We can see here that some code doesn't compile, like page $. This is something that it invented, probably because it's a Vaadin view. Page $, exists in TestBench, but not Playwright, so it mixed things. So AI doesn't produce perfect code. And here you can see as well that it tries to evaluate a JavaScript in the page, simulate and read messages. And this is quite weird because we don't have this in the HTML that we copy and paste. It's not in the code, so it's something that it invented because it's not also in the Playwright API that it could visit in the internet. So it's an hallucination from the AI. So the next demo is that we are going to run the test that we had. So I have this test. I have copied and pasted in my IDE this test. And what I am going to do right now is to play my test. Well, first I am starting the server, okay? And then the test doesn't compile. So the first step that we should do after asking the AI for something is try to fix what it did wrong. So I have fixed the code, so I can try to run test, for instance, this test, and see what happened. Well, it is running. It opens the browser, it visits the page, and, well, it fails. This failure, for instance, is saying that, okay, the expected size was 100%, but it's 555 pixels. That is already, in my opinion, is a bad test, so it shouldn't test this kind of stuff. So in order to have better results, what we are doing in this experiment is to improve the prompt. So this is the original prompt that we used in the demo, but how to improve the prompt? So if we focus on actions that change the UI and skip static elements, like here, focus on user actions that cause UI changes, and also avoid things, verification of styles, layout sizes, etc. It improves, but also it improves if we break it down in steps. So you can see that your objective is this. They are inputs which were, so we are changing a little bit the prompt. Basically, it's the same idea, no so much changes, but we structure in inputs, guidelines, and then specific instructions. And we also leave place for nodes, for instance, for give more context. We are, in some examples, we are putting here examples or snippets how to test a grid, because the grid is difficult to test. So that helps. So once that we have improved this prompt, we get these scenarios. So right now, this scenario or this Gherkin output is better. So it has the feature better described, and also it is talking about the chat view. it's talking about my namespace. So the test is going to be placed in the correct namespace with the correct name for the test. And then it is describing the scenario quite better, and it's using better selectors for everything. Okay. Now instead of 8 scenarios, we have 3 scenarios, and everything makes sense. So switch the chat channel, send a message, and test that unread messages update happens. So instead of testing if a view has a size or something. And this is the output of the Java code. So the Java code now is more compact and more it's better. So we have a setup, more concise, and also we have the 3 tests. Now there are not errors. At least it doesn't mean that the test pass, but at least the test compiles. So improving the code is important. Let's see what happens if we run this code in our IDE. So you can see that the code is using correctly the namespaces. It is using private assertions. It is testing. And it's using locators in the nesting locator, so it's easier to locate things in the UI. So we try to run the test. And yeah, it fails. So it fails now. Why is failing? Well, it's failing because the selector is not correct. Okay, and we are going to see how to fix that later. Okay, I have another demo, which is the demo about consistency. You can see this is the previous test. So I run this test and I get this Gherkin file. I have here 5 scenarios. I drop these results and I rerun again. And I have less scenarios. I have 4 now. And then if I run it, I have other scenarios. So it means that that the AI each time produces different things. So it's something that is non-deterministic, and so you cannot trust that the test is going to be generated again with the same output. All right, and so challenges in AI test generation are that we should fix somehow inconsistent results, or not compile code, or wrong selector, or improper API usage. But one of the most important challenges is to generate good tests for complex components in the view, like grids or CRUDs, etc. And it makes AI-driven testing difficult to implement in real projects right now. So the solution for that is that we have to refine prompts, so optimize the prompts as we saw, and do manual reviews. So don't expect that the test that produces the AI is going to work at the first time. And also we need to add example test code to the prompt. So if you have already a view with a test that it works, you can provide this context so as the AI can compare what is in a view, what is in the other view, and try to use the same patterns. And as reference in Vaadin experiments and implementation, we had good results processing the Gherkin file. So we pre-process the Gherkin file, and we extract snippets that we have in a database, handwritten snippets for each component in Vaadin, and then we improve the prompt given this context. And now let's introduce the UI Test Generator. It is a new experimental product we have delivered in the latest Vaadin versions. And Smart Delta is, so UI Test Generator is part of Smart Delta. Smart Delta is a project that helps to automate testing for software changes in continuous development. It's an international research project supported by a European program. The project studies software updates to check if the quality improves or gets worse after you change your code, and provide insight and suggestions. And one of the companies involved is Vaadin, and we are working on research for the UI testing. So the Vaadin UI Test Generator that we have developed, it uses AI technologies to create UI tests for Flow and Gila views, and it can be used as a Maven plugin or as a Java library, and it works in two phases. First, generating the Gherkin scenarios, and second, creating the Playwright code. Here is how the UI Test Generator works. So in the parser phase, it reads Java classes, and it uses Selenium to extract the HTML. So instead of, to do manually the copy and paste of the Java code and copy and paste of the output of the outer HTML in the page, it does automatically. And then generate the Gherkin scenarios. And then this, in the generator, we generate the code from this Gherkin code. So we have a Maven plugin. And the Maven plugin is quite simple because you have the parse goal, and then you have the generate goal. So two steps. Note that you need the appropriate token in your environment to use the OpenAI API in this case. So let's see a demo regarding the Maven plugin. So we start our project with Maven. This is the Vaadin showcase. It is listening in the port 8080. So we go to another terminal when the project is running, and we run the project with the parse goal. So the plugin is UI Test Maven plugin. When we run this, it does certain things like it is visiting the page using Selenium, the hello world address form. It is visiting all the views, and then it takes the HTML code, and then it produces the prompts, and finally it creates the UI test YAML file. The UI test YAML file contains all the Gherkin's files for all the views. And then in the second phase, we can call again the plugin, and with the generate goal, it reads the UI test YAML file, and then it creates or visits all the views and creates a test file for all the views. Yeah, so you can see here all the views generated. And then when we go to our IDE, you can see that in the Java folder, we have tests already for all the views in our project. It is unit test using Playwright. And then in the front end sources, we have tests for TypeScript. So we are doing tests for Gila views in TypeScript and for Java views in Java. Actually, you can use any combination, but for us, makes sense that people writing the UI in TypeScript test the UI in TypeScript. So you can see that here we have code in TypeScript. It's similar to Java. I mean, the API usage is similar to Java, and you can run tests, Gila tests directly for your IDE if you use IDEA, but not if you use other IDEs. Okay, so the next thing is Copilot. I think you are already familiar with Copilot, it sets up the necessary dependencies and configuration, but it's still experimental because tests might not compile correctly, as it was said, and successive execution could overwrite previous generated tests. So let's see how tests can be generated with Copilot. In this demo, we have this Gila view. We open the Copilot by clicking in the corner icon, and then we open the UI Test Generation window, and we click on the Generate Test for the current view. And then you can see in the output of your project that it is generating, it is updating actually the POM file, etc., and generating the view. So it sets up your project with using the JUnit platform, the Playwright, etc. And at the end, it produces this test. So it's a test similar that we saw in previous demo. And yeah, that's okay. And now we have final demo. This final demo is, we are going to see everything that we have seen before, but we can know how to fix our test. Okay, so now we are going to use the address view, address form view, instead of the hello world or the chat view. And what we are going to do is to run in our IDE in debug mode our project, that is the normal way. And then let's go to the address form. Let's open Copilot. And now open the panel for the test generation and generate a test for the current view. This view is a form with 5 fields and also 2 buttons. Let's see what the AI generates for this form. So yeah, here you have the test. We have, as you can see in the previous, we have the before each. And what I'm going to do here, because I am going to run the test, is to modify, well, you can see here that we have the default timeout, we have the annotations, etc. But what I wanted to do here is to configure the run so as we run the test in non-headless, so we can see the browser, how the browser is open, and also set up the slow motion, because Playwright by default is headless. And let's configure the slow motion to 500 milliseconds so we can see what is happening in the UI. You can see that we have locators for all the, it looks quite good. So sometimes it uses locator with CCS selector, but sometimes it uses better selector or recommended selectors like aerial roles, and with the content of this area role, and it is testing if it's visible, all the elements there. Then it fills all the, it has tests for filling each of the fields in the UI, users fields, city, state, address, etc. And then it has a test for clicking the save button, and it has a test, well, it shows or it expects a notification, and user clicks in cancel button, but it's not compiling. This is something that happens quite often. So why it doesn't compile? Well, it is using this all match method, and this all match method doesn't exist. So it's an hallucination of the AI. It has invented this method in the Playwright API that doesn't work. So what I am going to do is just replace that with a regular for loop, and I am getting from the text field the list of all the fields, and the same with the for the other. Okay, and I am just using the same assertion, not changing right now the assertion. Okay, so once that the test compiles, we can try to run all the tests. What happened? Probably something fails. Yeah, it is opening all the tests at the same time, address form, always, and then filling things depending on the test. So the first test that fails is this one. So element is not a select element error. So the selector here is wrong. And what I'm going to show you is how to compute the correct selector for ourselves. So Playwright has a CLI command line that you can use for starting the code gen. Code gen is a generator of code for Playwright. So it opens inspector of a browser. So you have a browser, so you can visit your website, visit the address form, and then because the select was not working, we try to select something here, and well, the state 2 in the selector. And if we go to the inspector, it has recorded something. We select JUnit Java output, so we can take this code for selecting the state. So it clicks on the state, it selects something, and then it presses escape. That is, there are the action that we did, and then replace the selector by this. Then click on it, and probably it works. Let's see. Yeah, it selects the state 2, so it's working. The test is green. So let's do the same with the other select. Let's go to the browser and select something from here. Well, country. There are states as well in the country. It's just an example view by starvaadin.com. But yeah, let's do the same here. Okay, let's run the test. Yeah, and now, okay, it selected the state 1. Good. Now we have the click save button. It is red as well, so it failed. Let's see why it failed. So as you can see, it's not filling anything in the, and it's failing when it clicks save button because Vaadin notification is not found. But first, let's fix that it does something. So because we have already methods for filling the fields, let's use them here. So user fills the street address, the postal code, the city. What else do we have? The state and the country. All right. Now we have data there. If we run it, we can see that the data is filled for all the form. Yeah. And then save is clicked, but there is no notification. Okay, because there is no notification. Well, this check of the notification is actually a hallucination from the AI. And yeah, you can see that it's an hallucination because you can see here that the save button doesn't have any action, and there is not a mention to notification anywhere in our code. So it's something that the AI took from the internet. So it's normal that when you save in a application like Vaadin, you show a notification. So let's implement the method, the click event. And then when we go again to our test and we click, probably we see that the notification is shown. Yeah, it's shown in this corner. Well, there. Yeah, the notification on. Yeah, And why is failing? Well, it's failing because the selector is not Vaadin notification, but Vaadin container. So this is something that we should fix at some point in UI Test Generator, because it's a known issue. So Vaadin notification creates a Vaadin notification container for the content of the message, because it detached from the UI to the body DOM, and yeah. Let's see if it works now. Yeah, notification should be there. Yeah. Okay. So we have green test, and then in the cancel button, it happens probably similar things. So let's start filling the form in the same way with the same data, and then try to run. Well, it doesn't run, and it doesn't run because AI disable the test. You can see here the disable. So because when it cannot implement all the behavior in the test, it disable it. So let's run again. Okay. It clicks cancel, but nothing happens. Yeah. So the street address is still there, so it's not clearing anything in the UI. So probably it is not implemented as well. So let's go to the cancel button and implement in the same way that before. So now in this action, we should take all the fields in the UI. So the fields has this kind of of names: text field, text field, text field, and then select. So we clear everything there. Let's save it. Go to the test, run again. It opens. Yep. And it is clearing, but it's failing. Why it fails? Well, it fails. Let's see what is the error. So it is checking the attribute value empty, but locator null call. So there is not such attribute value. This is because in web components, the value is not an attribute, but a JavaScript property. So we chain has attribute by has JS property, and then so that's something that we need to fix. Okay, and the test is fine. So we can fix that with more snippets indicating to the AI that normally you need to use this. So let's remove this headless false here and the slow motion parameter, and then you can see in the corner at the right that is running all the tests at one, and all of them are green. So that's ready for the continuous integration server. Let's do the same with a Gila basic hello world view. So this is Gila. You know that you can combine Gila and Flow views in the same Vaadin application. So we click in the Copilot, we open the UI Test Generator, we generate it. And we should have at some point this hello world spec TS, which is a TS file. I am using here Visual Code, and Visual Code doesn't allow you to run TypeScript test inside here. So it is a Playwright test. It has the same stuff than before. It has a default timeout. It has the cases to test. And let's try to run this test. You can see everything. Yeah, it has Vaadin notification. It should be Vaadin notification container as well. But yeah, let's see how we can. Okay, let's stop the code gen. And then if you see in the package.json file, the Copilot added this line scripts. test. So what should you should run for testing, and you see that it runs Playwright. So let's run the test here. So we can execute npm test. Test is the name of the script, and I want to pass a couple of parameters to the npm Playwright test. Is with menus menus and then menus menus UI. It means open a UI, so I can play each test with a button, and then headed means non-headless. Okay, so this is the UI, Playwright UI. It's for running tests in JavaScript. You can see that it opens as well the browser, and yeah, everything works, but then in notification. You can change the code in the IDE, and actually you can rerun the test without, without having to refresh anything, because it automatically recompiles the TypeScript code. And now you have it working. Yes. Yeah. Perfect. And now, where is the presentation? Here it is. Okay, so
it's actually me who is sharing the screen now. So, sorry about that. I thought you had some challenges with the screen.
Okay. All right, I can continue with the. Let me. Okay, so conclusions. Let's see, where are you? Yeah, the next slide. All right, so to conclude, we have seen that Vaadin views are valid for automatic test creation. Also, we have seen that how AI can improve software testing by increasing coverage and reducing manual work. However, we need to refine AI prompts for accuracy, and we still need human review. And in any ways, adopting AI can be a revolution for software quality assurance. And as a big summary, we can say that we are ready to embrace AI to stay ahead in software testing and aim for continuous improvement in testing processes. And AI can help to automate repetitive and time-consuming tasks. And Copilot and UI Test Generator should be a good tool for you in the future. Yeah, that's everything that I have to present today.
Awesome. Thank you so much, Manolo. There was lots of information, and I was also happy to see during the presentation that we did receive quite a few questions regarding the presentation. So let me just scroll down a bit to go through the questions. All right, so let's start with this one. Why do you use two phases to create the test? I mean, why the Gherkin file? And there was another very similar question. What is the advantage of using Gherkin as in-between step instead of asking ChatGPT directly for the Vaadin test code?
Yeah, this is a recurring question. So the thing is that we are in the frame of or in the context of this Smart Delta project. The Smart Delta is not only for testing UIs made with Vaadin, it's for testing anything. So the idea is that you, or even you don't have access to the source code, so anyone in the QA department can create the test of an application just writing their Gherkin files. So basically, they can write Gherkin files manually, or they can produce their Gherkin files somehow else. And also maybe the QA needs to create tests with another tool, not necessarily JUnit or Playwright or whatever. So they want the Gherkin files from their developers how to test your UI. So basically, it's because of in big companies there are two departments split in the developer department and then the QA. So it helps in this way, and also because you can have in processes in the between, like we do. So we take the Gherkin file, we inspect the Gherkin file, we go to our local database with snippets, and we put in the context specific snippets for these scenarios. And then the code generator for Java or for TypeScript, it's better. Yeah.
Cool. Thanks. All right. The next one. Why did you choose Gherkin and Playwright instead of good old Selenium or TestBench? Is it out of bounds for ChatGPT?
Oh, well, Gherkin in general is because it's a DSL that is good to use. It's actually is from a different project, but the specification is well known in software development. And then Playwright is because Playwright is open source. Playwright allows you to have Java tests and also TypeScript tests. And but we have Gila and we have Flow, and we have many users using Gila and they want to test the UI. And also because this is in this Smart Delta context, we cannot, we shouldn't deliver tests in TestBench, even though it's a tool, it's a commercial tool for testing just Vaadin application. So you cannot test other application than Vaadin with TestBench. And also is so we need to deliver some solution for our users that also covers the open source material. Yeah.
Okay, cool. Then the next question, would this also work for more complex views? It has already hallucinated with a small class with comparatively little HTML. Wouldn't it be more time-consuming to fix the problems with more complex views than to write the tests themselves?
Yeah, absolutely. So the thing is that the first phase, well, the UI Test Generator helps you to set up your system, so it automatically put everything in the POM file and configure the package.json. But this is just one-time thing. But still, it creates the skeleton for your view with only one click. So you have the test for the current view in your application just written in your IDE, and it creates, even though the scenarios are not well implemented, in general, AI makes a good job selecting what to test from your UI. Obviously, for complex UI, it doesn't discover anything. So that's the reason why we put as well the HTML. Also, the HTML has some clues about which components we are using, and in the future, when we put more and more snippets, when you see, for instance, Vaadin grid, it means that there is a Vaadin grid in the even though it's a separated, I don't know, add-on or whatever that puts there the grid, we can discover that it was a grid there, and then if we have a good snippet for testing the grid, probably the AI could do a good job there. But basically, it's because you save a lot of time just writing the skeleton of your test. Yeah.
Cool. So are you saying that the recommendation is to start with the AI generated test cases and then start to maintain it manually or by human developers? Would that be?
Yeah. Actually, the UI Test Generator right now doesn't have any control to override your test. So if you run this, the reason it is experimental because it overrides. Yeah.
Okay, cool. Then we've got a question regarding testing TypeScript code. I think that got already covered. So yes, it is possible to generate test cases as well for TypeScript views, like for instance, Hilla.
Yeah, it is. So.
All right. Then the next question after this is, can I use this methodology for any testing of any application or code I have?
Yeah, this is the reason why this presentation is in this way. So you can experiment with this prompt. You can, instead of copy and paste in a Java view or a Flow view, you can have a React view and try the same. So this mechanism is the mechanism that it has worked for us the better. Obviously, the UI Test Generator has more sophisticated prompts inside, and it has, but basically is the same workflow. So you can do that by yourselves. And UI Test Generator is able to edit your code, connect your ID to click and open the view and so on. Yeah.
Cool, thanks. Then a bit longer question. Is there a way to use AI to be able to ask questions? Human questions, like for instance, how large can the comment field be in terms of maximum number of characters? And get the answers from the available scenarios in the feature files in Gherkin.
Oh, well, I don't follow exactly what is asking about. So, in general, can you elaborate the question, because I don't know if it is asking about, yeah, in Playground you can configure, depending on the model, how many tokens you need. Yeah, and UI Test Generator configures to the maximum in the model that we are using, so you cannot interact more with that. Probably in successive version of the UI Test Generator, we can, before generating the code, we can provide the option to edit the Gherkin file, so the user can optimize it in some way, or we can give the option to edit the prompt before sending or something like that. But right now it's not.
Okay, and to the person who asked this question, if you are not satisfied with Manolo's response, feel free to continue the conversation on our forum, vaadin.com/forum. All right, and let me take one more question here. Is recording a test case, like manually in browser with Playwright, and afterwards correcting the tests with AI also possible scenario? And they continue that for our findings, the recorded tests are not referencing the elements the correct way. Maybe AI could help with that. Any thoughts on that?
Well, the normal way in Playwright is to record with this tool that we have seen, and then it produces the code, and then obviously it doesn't work as well. Even though you are using Playwright recording, it doesn't work because it could be something inside, Shadow DOM, or maybe there is some IDs that changes from one execution to another, so they are, and things like that. But still, is a good tooling for recording. And then what you can do is, once that you have the test, maybe you can send this to the AI as well with the code. You can mix everything. We have not experimented this, but could be a good idea. Send the source code of your view, also the HTML, and also the Playwright that you record, and then try to make a test with this. Probably it works better. Yeah.
It would be wonderful to hear from you on forum. How did it go? If you tried out and get some results. All right, we are almost at the top of the hour. It's time for us to say thank you very much for joining this wonderful session with Manolo and generating test cases with help of AI. And as said, we would really love to continue the conversation with you on the vaadin.com/forum. So please feel free to join the conversation. If you have any questions regarding the topic of this webinar or any Vaadin-related questions, feel free to use the forum. And as usual, we'll send out the webinar recording to you, as well as the slides in a few hours after this webinar, so very soon. Thank you all, and I wish you a great day. See you next time.
Thank you. Bye.
Bye.